environmental assessments, remediation, a lot of civil structural engineering, as well as materials testing. And it's the materials testing and inspection world that I'm going to speak to today when I talk about quality and efficiencies for material testing. If any of you have ever driven by a construction project, I'm sure someone has at least once remarked, you know, what are all those guys doing standing around? Why aren't they working? You know, is they standing around observing something? And a lot of the times that's because you've got various inspectors from state agencies, from the contractor side, from the owner side, all out there to make sure that whoever it is that drew the straw to do the test, to do the inspection, is doing it absolutely right. So it is a world where quality is often thought of in terms of how good is the quality of my material right here, right now? Do I have a result that's going to allow me to put down this concrete, put down this asphalt, put in this rebar, and not have to worry about it having to be ripped out later to my expense? So it's a world that's grown up very dedicated to paper and having things written down on paper as the process goes along, having that result right there, and then kind of forgetting about that record or that paper until some type of litigation issue comes up, and then suddenly everyone is scrambling around saying, where's the record, and who do I point my fingers at to say, hey, this concrete failed, it's your fault. So what I basically want to just put forward is it's an industry that is struggling to come into the 20th century when it comes to records and documentation, much less the 21st century, but it's something that is happening. And that's really the basis of what I want to speak to tonight is what we've been doing in our firm to try to haul ourselves into the 20th century when it comes to our recordation. Give me a bum. There, okay.
The screen.
It's not intuitive.
It's not intuitive.
I've been a past board member of this section, and currently, and for the last 2 years, I've been on the board for ASQ's Design and Construction Division. And our goal is to really push the use of quality management tools in the design and construction world. I think at one conference, someone got up and said, if you take a look at all the industries in the U.S., you've got a scale of 0 to 10, with 10 being really good acceptance of quality tools. Over here, you've got pharmaceutical and aerospace and healthcare, and design and construction is still way over there. So our goal right now is we're trying to put together a certification package so that we can have certified construction quality managers, recognizing that there are some differences between what a construction quality manager does and what a more traditional quality manager for another type of firm does. And so part of what I like to do is just tie back whatever it is that I'm going to talk about to what we're trying to do in the division. And one of the big things we push in the division is, it's elementary, it's plan the work that you're going to do and then work to your plan. Have your quality objectives embedded in the work plan that you create for the work that you do, so that you're not just deploying people out there with no sense of what are the specifications I'm responsible for knowing, what are the standards I'm responsible for testing or inspecting to. And so a lot of, again, what this presentation will talk about is that planning process. So for the project that I'm going to talk about today, it's the Charlotte Area Transit System Blue Line Extension. Has anyone ever been to Charlotte, North Carolina? A couple people? It's a great place. I recommend it. They have a nascent light rail system, and their blue line is the one currently that they're expanding. And it's not a whole lot of mileage that they're expanding, but as I get into the project details, I think you'll see how complex the project is. Kleinfelder works directly for the Charlotte Transit System. And so as we were looking at this project and trying to figure out, well, what are the quality requirements we have to do, we came to note that there were several areas that we had to take into account. One, we have our own company quality requirements. Kleinfelder, for its corporate work, runs to an ISO 9001 compliant program. But then we have to add to that our testing laboratories and our inspection services. Testing laboratories typically have to conform to the ASQ R18 criteria for quality. And inspections usually have to be done in accordance with ASTM E329, which lays out quality requirements for agencies involved in the testing or inspection of construction materials. I do expect you to remember all these acronyms. There will be a test. So, long story short, we have a lot of internal requirements that we have to take care of and make sure that we're abiding by. But then we also have to take into account our client quality requirements. This particular project is funded by the Federal Transit Association, the FTA. The FTA has their own quality system of 15 requirements that looks remarkably like ISO 9001, except where ISO has maybe 8 sections, the FTA has 15. But that being said, we still had to figure out how are we going to marry up all of these internal company quality requirements we have, as well as making sure that we meet what the client needs us to meet so that they can go to the FTA and say, look, our project was done in compliance with the requirements, don't cut off the funding. And so the way we did that was to develop a project management plan that it identifies the specifications that we're going to have to follow. It identifies our process for addressing nonconformances, both process nonconformances like you might be used to, as well as if someone comes across a nonconforming item during an inspection, what is the process for getting that item either okayed for use, or does it have to be rejected? What has to happen in terms of its disposition? So a fairly robust project management plan was put into place for this project. And basically all this is by way of saying that we made our project manager's life pretty difficult for a while as he had to come up with the plan. So what this got into, as we were looking at how we were going to perform on this project, was how are we really going to be efficient in terms of documentation and record keeping. Because while the materials world is still, as I said, kind of dragging its feet in some ways, the design world is leaps and bounds ahead of us. In the design world nowadays, it's pretty rare that you're ever going to see someone show up with a set of blueprints on the design side. Everything is getting emailed back and forth. They're using BIM, they're using AutoCAD. They're pretty much going fully digital. And so there are cases where the folks will be building along, going along, and your inspector is showing up, and they've got to do some inspection work, but they don't necessarily know if they've got the right plans or the right drawings to go with the construction project they're on, because again, this digital world is moving so fast. So we know that we've got to speed up, but at the same time not speed up to the point where we lose control of what we're trying to do. So what are our specific processes that we have that are paper heavy? Well, one, we've got all the specifications that we have to follow. We've got all of the procedures that we have to have in place. Procedures that say, if you're going to go out and look at some rebar and determine that is acceptable or not acceptable, what's the process that you have to follow? The same with if you're going to go out and do a compaction test. What do you have to do in terms to make sure that the soil has met its compaction? And of course, forms. Our data collection instruments are key. If specifications change, your data form may have to change in terms of what was previously considered acceptable. Maybe it is no longer acceptable. Or you might have a situation where, okay, if it's on this side of the room, I only need you to have soil compaction at 90%. But if it's on this side of the room, I need you to have soil compaction at 95%. So you need different data collection instruments potentially to capture that information. Traditionally, the work process has been the inspector goes out, they observe, they do their tests, they write it out on their report. Maybe they take some photographs of what they've seen. They may also capture some documentation from the office. Say if someone's doing a concrete test, they'll get a batch ticket from the truck that indicates what batch of concrete was delivered. So you get all this paper that starts piling up, all of this documentation. That usually then gets turned into someone to do the review of. They'll sign off on the report, and the report will then get transmitted finally to the client. It's so much easier for the client if they can get that report within 12 hours, 24 hours, something very close to when the material was laid down, because that way if something's gone wrong, they pretty well know that they've got to take it out. But even better, if everything's gone right, then they know that they can continue building on top of the material that they put down. So not just with paper being a lot of fun to process and taking time to process, the review process has just taken a while. Another thing that we had to look at was how are these records being archived. It's become very common now for the prime contractor in a lot of these projects to set up either an ProjectWise or ShareFile or some such program like that, a project-specific cloud